Today's presentation is an evolution of fretboard slotting that I've prepared for the STEM Guitar Summit 2022. I'm Doug Hunt, and I'm at Southern Wells Junior Senior High School. The first method that I've used to make fretboard slots and had students use is from around 2009. So basically a crosscut sled with a pin and a series of holes as stops. And you line the end of the fretboard up with the pin and take your cut and advance down the row of holes. This worked really well for the first few hundred fretboards that we made in-house and for the STEM guitar project, but the holes wore over time and it compromises slot location accuracy. Using it for extended periods of time also contributed to back strain. So the next idea was to use a dedicated station with a sliding compound miter saw. The idea was to build it on a much taller table to reduce back strain for repetitive use. And it was going to have a custom milled fence and a special sliding stop that would line up on detents for where the fret slots should be located. The image on the left, you can see how much taller that table is compared to using a table saw. The key to the whole thing was a toggle, or I call it a toggle, attached to the top of the sliding stop. And I pressed a marble into this block of plywood here, and that marble lines up with each one of the detents. The strips are made on a CNC machine and a 1/2-inch ball nose. It allowed for multiple different fret scales and fret spacings to be used, whereas the crosscut sled was dedicated to one scale. A lot of the accuracy still depended on operator and muscle memory. So if you were in a hurry, you could miss a strip and cut a slot in the wrong place, but it was still overall much faster, much better than using the table saw. But it had in mind for a while to have a fully automated machine, and I wanted basically so you could change the scale length and the number of frets on the fly, and whether or not to have an 1/8-inch string nut slot for a flat neck or a scarf joint angled neck. Scott Klein at Purdue University had built a machine that he called Sliding McSlotface using a heavily modified circular saw and a microcontroller, but it just never really worked very well. Components that I selected for the machine that I'd build with students were an Arduino, a very long ball screw, a couple of pneumatic air cylinders, some 24-volt operated solenoids to control the airflow, some flow control valves on the cylinders. We'd need some control circuitry for the stepper motor on the ball screw mechanism. We need some relays to turn the solenoids on and off for the saw motion, and also to turn the saw motor on and off for the cutting. Additionally, we've got an LCD screen for output display, a PS2 joystick controller for input, and an emergency stop switch. The block diagram for how this would work is shown here. The Arduino really is the heart of the whole thing, controlling the stepper motor for the ball screw, the LCD screen responding to the PS2 stick, limit switches on the ball screw, emergency stop button, as well as turning the relays on and off for the motor and for the solenoids. Where we began was fitting the ball screw to the existing table as a retrofit. Figured if this was going to work or fail, this was the place to start. Once that was installed and connected with the sliding stop, replacing the detent strip, we wired the motor up with the 293 on an Arduino shield, plugged into all the pins, and then this shield gave us the access to all the other pin lines with screw terminals. To hold the workpiece to the table, we need to have some feather boards pressing both against the custom milled fence and pressing down into the table surface. The pneumatics had to get worked out also, and the big challenge was how to connect the cylinders to make it have the saw slide back and forth and swing up and down. And you can see one end of a cylinder is mounted in the socket for the clamping mechanism when it's used in a traditional sense. And the other end of that cylinder presses against this baffle, which is kind of sandwiches the original stop at the end of the rails. So when the cylinder closes, it makes the saw slide out. When the cylinder extends, it makes the saw retract and slide back in. To get the saw to swing up and down, again, took a little figuring as well. This is really the only modification made to the saw, is remove the handle and added these layers of laser cut plywood. And each layer is a little bit different in order to fit with the molded bosses and so forth on this saw housing. The end of the laser cut pieces are all connected to this block of oak, which has been fitted to the clevis that is shipped with the particular type of cylinder. The other end of that cylinder is mounted on this block of wood, and that block of wood is attached with a hinge because as the saw swings, this angle that the cylinder sits at changes. And by having a hinge on here, I didn't have to worry about making any other compromises in the design. So here's the whole thing rigged up with the airlines. As far as the electrical controls go, the Arduino with that L293 chip is the center of this on that shield. The whole thing's powered by a 24-volt power supply. The relay module for the solenoids and for the saw motors here, 2 of the relays had to be used together in parallel in order to handle the current draw, especially when the saw motor first starts up. So all 4 relays are used. And these are the solenoids. Question? To turn the whole unit on, there's an on-off switch. And the on-off switch is tied to this outlet. This outlet is where the 24-volt power supply plugs in. And the other outlet is switched by the pair of relays. And this is for the saw motor. As far as the software goes, it's written in a language kind of like C, and it's the environment is free when you purchase for download. So it makes it easy to get access to. And everything's driven by a menu system and the PS2 controller. There are some presets for common scale lengths and numbers of frets and optional string nut slot, and modifying some slot locations for better intonation. But the algorithm for the software is regardless of the scale length, it calculates all the slot locations and then determines the number of motor pulses that are required to advance from one slot location to the next. And then when it's traveled to each location, it stops moving the fretboard, and it cuts the slot and then resumes moving to the next slot. There's an emergency stop button that's programmed into the software so that at every movement, it checks to see if the switch has been pushed, and if so, it shuts the motor off, swings the saw motor up and retracts the saw back, slides it in away from the workpiece, puts a message on the screen, and everything shuts off. To use the machine, you select which program you want for the scale length and number of frets. After that, the machine zeroes out against the limit switch on the far left. Then you install your fretboard. And the fretboard does need to have a hole drilled in it for the screw to travel in. The fretboard will drift a little bit if this is not attached. So pinning this with this screw keeps the fretboard from drifting when the saw goes across. You use the controls to advance the fretboard so that the end of the fretboard lines up with where the saw blade is. And you select the start option, and the machine does the rest. At the end of the cycle, you back this screw out, slide your fretboard out, and repeat the process, going back to zeroing the machine and installing a fretboard. So if you've got production work to do to make multiple fretboards, it is fairly easy to get a cycle going. In the final analysis, this machine, works very well. It's highly accurate with known fret scales, and is consistent from one fretboard to the next. The common scale lengths that we use are 24 3/4 and 25 1/2, either with or without a string nut slot. And the string nut slot is cut by making 3 slices, and you'll see that in the video. It defines the edges of the fret slot, and it makes a cut down the middle, and it's very easy to pop out the waste and then use a file to touch it up. So on this fretboard at the bottom is actually a 30-inch scale length fretboard with 16 fret slots, and it lets us make a bass in the same form factor as an electric guitar with the same truss rod and neck blank as our starting point. So let's see this in action. Now first you'll see the carriage zero against the limit switch on the far left. So now we're going to cut the string nut slot. It's going to do it in 3 passes. So the first cut defines one edge, there's a center cut, there's a relief cut, and a third cut that will define the other edge. And those 2 little strips of wood will be very easy to pop out. After this is done, you can go back with a chisel and clean that slot out. And we're cutting the first slot. The blade runs the entire time. And the timing on this actually has some simultaneous motion if you watch closely between raising the saw and the fretboard beginning to advance. It's all timed out. And there you can see the carriage that pushes the fretboard. Here's the stats on which slot we're cutting, scale length, how many slots we've got total. TOG is a Technology of the Guitar Reference, a book by Mark French, where he talks about moving the first and second slots to improve the intonation slightly. And that means that feature is enabled. The featherboard is doing their job, holding the fretboard to the fence and to the table. It shows the motion of the cylinders in action very nicely. You can see the stick that advances the fretboard, and it slides in its carriage in the stop. So you could put in a longer or a shorter piece of wood for a fretboard break. So we've done full-size basses with a 34 scale fretboard. Have also done small strum sticks and cigar box guitars with a short fretboard as well. And this shows the stepper motor spinning that ball screw. We're almost finished. Now the fretboard is complete. The small screw can be backed out, the fretboard slid from left to right, and the process can be started over again to make another fretboard. Thanks for watching.